Hi everyone, my name is Kwasi Koma. I'm the lead AI architect for SambaNova Systems. So a little bit about SambaNova Systems. We're a full stack AI company and we offer inference using custom silicon and we use it to kind of power agentic applications. We think more effectively and fast using something called data flow technology and the RDU. We're based in San Francisco, and my background has been kind of in machine learning and data science, and I've been working on applications from vision to financial, and now I've been focusing on agentic applications and building them up for our client base as well. So this is going to be a great session. We've just launched a new SM50 chip, which I think we'll share the details of, and that kind of really focuses on these agentic workloads, basically providing low latency but with high throughput and a kind of low total cost of ownership on the hardware. And I'll talk about it a little bit in coming sessions. But for today, what we're going to do is we're going to kind of talk a little bit about what's inside these coding agents of ours that have been kind of taking the world by storm, and we'll break those down and we'll do some code and we'll kind of get into some of the concepts that underpin these agents, and hopefully you'll come away with a much better working knowledge of these agents. And in the next session we'll be getting into some of the concepts and building one using some code. So without further ado, I'm going to start sharing my screen and we'll start working through the stuff. Okay, so just double checking that everyone can see that. Perfect. Excellent. So basically what we're going to do here is we're going to break down the coding agent and the rise of them. So before any further ado, let me just move this. So we're going to, this is series one of six in a webinar series. And this one, we're going to talk about the rise of the deep agent. The second is going to be where we're going to be building our first agent hands-on. The third is around context engineering, which is the concept of how you can manage the context, i.e. what the agent sees and why that's super important for getting good results and managing your token usage and things like that. Fourth, we're going to talk about skills, tools, and MCP, kind of what you give to your agent in order for it to go out into the real world and do things. And the five, we're going to talk about multi-agent systems when you start working on more complex workflows. And six, one of the most important is kind of like testing and production. And that's kind of a day zero thing, but we'll have a whole session to go through that as well. Each session of this is kind of standalone, and you can take each session as it is, but we would recommend that you kind of look at all series in this order so you get the best experience out of this as well. So as you can see, we're having a real kind of coding agent moment. Coding agents are probably the first AI agents to achieve mass adoption, I would say. We have millions of developers using them daily. And I think here we're actually moving on to people who aren't developers who are using them. So things like Claude Code are really, really kind of gaining, I would say, usage from business users, people who are not particularly technical. And it's really kind of their first introduction to how they can get AI to build something for them. And obviously, we had things like ChatGPT, which was the kind of big AI moment. But here at SambaNova, we've been thinking about how to speed up these agents in the way that we use our chip architecture. But what we're seeing here is, cursor evaluation. We've got 25% of code being generated. This came from Google. And, you've kind of got 50% of AI agent activity is software dev. And it's driving huge valuations and huge productivity gains. And here, you've got some of the tools that you probably have heard of and you use every day yourself: Cursor, Winset, Codex. But what we're really going to talk to in this session is what actually goes into these agents that build these kind of applications that you're seeing so much of. So the first thing that you can see is that most custom agents still fail. Now, one of the things that we get asked a lot by our customers is why. And there's a few reasons, this is not exhaustive, but these are some of the common patterns as to why agents fail. We have something called context collapse, and this is where the context builds up over multi-step tasks, and the agent simply loses track of what it has to do and what's important. And so it fails because it just can't keep up with the complexity of the task. The next is kind of no planning. It kind of wanders aimlessly. The third is that tools break, and the fourth is that they can't evaluate whether something's correct. And this is why evals are so important. Um, and now, what coding agents get right, and I think by coding agents we mean agents that are deep agents and have a harness. And this term harness is kind of the great work that's been going on by some of the pioneers in this industry. The concepts that I'm going to talk about, I kind of stand on the shoulder of giants here. It's stuff that's coming out of Anthropic, coming out of LangChain, and we'll be using LangGraph through this course. And they have really thought about this idea of a harness, which is all of the kind of software and the engineering that goes in and around the agent to kind of work with these concepts of memory, tool ecosystems, eval, and skills. And coding agents now have got this right. And I would say that Claude Code and these other agents that you're starting to see now, the harnesses that they're built around really, really do address some of these things. So firstly, you've got things like persistent memory. You've got a rich tool ecosystem. However, what we'll talk about is that there aren't too many tools, so you don't get this kind of tool bloat. And they're continuously evaluating, right? So you might see the coding agents. The good ones, they evaluate their work, and they try and verify that their things, that the solutions that they built do work. Now, sometimes they could do more verification, but in general, that's what they're trying to do. And then the last is probably one of the biggest things that's come out, and this is kind of composable skills. And a skill is something that we'll get into later, but it allows the agent to do something like, file ops or something custom to you or your business. And you basically write it out in plain text and tell the agent how to do it. And then it loads it when it needs it. So the next thing I'm kind of going to talk about is kind of shallow agents versus deep agents. So here what you're seeing is that you have shallow agents. That is where we started our agentic journey. So when people first started building agents, you kind of maybe you do a single LLM call, you do a tool execution, maybe like a web search or a Jira call or something to a custom database or something like that. The context windows were quite short, and this is not just an agentic limitation. This was just when we were doing shallow agents, the context windows of those models was just shorter. Context windows have grown dramatically because it's super important for agents, especially coding agents, to have as much context as they can when they load files to answer the user's problem. They were usually simple React loops, they were bounded tasks, and they had limited planning capacity. Now, what we're seeing with deep agent is a fundamental shift in the architecture of an agent and what it's capable of. And these are kind of highlighted by these characteristics on the right hand side. So you've got extended reasoning, the ability to spawn sub-agents. So I'm sure that you'll see on some of the coding tools that you use, if you pay attention, that when you ask it a task, it spins up a sub-agent that goes and does something. The third is being able to access a file system. Now, that file system could be virtual, it could be something that's on your computer, or it could be something just in the agent's memory, but it treats it like a file system, something it can retrieve. And then because of these three things above, it's able to run much more complex tasks. And so what you can actually do then is basically have sophisticated planning and reflection, something like, refactor this module and update all the tests, and the agent will go away and do that. So again, coding agents are probably the most widely adopted deep agents, and we're going to learn from their architecture. Now, of course, again, coding agents are a type of deep agent, and we're going to see more and more deep agents as we go, but coding agents have probably been the first mass adoption of these agents as well. So what I'm going to do there is I'm going to kind of stop just to make sure I don't have too many questions very quickly. Give me a sec. If not, I will continue. And again, I will stop for questions in the chat. So if you can just let me know if there's anything kind of urgent, and I will kind of stop to take any questions in the chat. So what I'm going to do now is to move on to the next slide. So what we've got here are kind of what I like to call the five pillars of reliable agents, especially of deep agents. The first is orchestration, right? So orchestration is how do we decompose a task? And this is super important because users are asking more and more complex questions to agents, right? You know, agents are moving from, just go and do a web search or go and do something to, go and break down this coding base and write me a set of tests and implement a new feature. That is a much deeper task that requires planning. And so that's what orchestration is about. The second is memory. Agents need persistence. They need somewhere to store down what they've done, and to remember where they've gone wrong so that they can make better decisions going forward. And a great example of this is kind of the .md files that you're seeing. So you have Claude.md, you have agent.md, which is the common architecture across different providers. And what those files do is basically give the agent a set of memories it can refer to, what to do, what not to do, and this can be written by the user or the agent. The next is tools, and these are kind of external capabilities and integrations. So you might have a tool that interacts with Gmail, you might have a tool that interacts with Salesforce, or you might have a web search tool that kind of just goes and searches the web. And then the fourth is evaluation. This one is super important. How do you evaluate that your agent is doing what it needs to do? And how can you measure performance in production to ensure that it's not drifting as data changes and that you can continuously improve and update the agent's behavior? And this kind of evaluation, it's very common to have a human in the loop to do some evals manually to make sure that the agent is actually fitting the needs of your kind of user and data set. So the fifth is probably one of the key ones. You can see why it goes across the bottom, is that because what we're seeing now, and this was something that first kind of was pioneered by Anthropic, who of course were kind of the pioneers of the MCP movement, is the fact that we're starting to see this. We're starting to see this. I can see some questions, so I'm going to try and have the chat here as well. So someone asked, is OpenClaw a deep agent environment example? Yes, I think the way that OpenClaw is built, it absolutely has those characteristics, because it is basically doing this whole pattern of it has a file system, it has memory, it has evaluation, and the biggest, I would say, differentiator between OpenClaw and its kind of virality is the fact that it has this whole thing like a webhook. So instead of you just talking to it, it can actually fire things back at you in the channel that you most use, like WhatsApp or something like that. But yeah, I would use that as an example of a deep agent in that question. Um, and then this kind of agent skills is a big thing from Anthropic, right? So this is kind of reusable, composable skills that anyone can write. And they aren't here to replace tools, they're here to kind of supplement them, right? Agent skills are something that anyone can write. Anyone can write an agent skill. It's in plain.md, and that makes them much more accessible for a business user. So to give you an example, if you are someone who is a case officer in a bank, you might have a skill that basically tells a private agent, how to, do case analysis, and you would go through the steps that you go through so that when your agent works, it has kind of all that kind of, the standard operating procedure as a skill. And that's reusable. You can use that on any of your agents or any of your workflows. So we'll talk a little bit about these in depth. And again, we'll see some of these in a coding example as well. So we'll be able to kind of see this in action, basically. So in the orchestration pillar, you've got this kind of how essentially the question is, how does Claude Code decide what to do next, right? So this one of the underlying principles of agents is this React loop. React is basically reason, act, and observe. So the agent reasons about the tasks, and then you can see that it plans. So you can see Claude Code generates a plan, it gets approval, and then it acts, and then basically it looks at the outcome of that, the observe, and then it decides what to do next. And this kind of goes on into a loop until it decides it's done. And if it's done, it will stop, If not, it will continue. And you can see this on the kind of right-hand side. This is a very common pattern. It's one of the there's a kind of founding paper that kind of brought this out, and it underpins a lot of the modern agents, including deep agents as well. Um, State management is also really key. How do you track progress through complex multi-file changes? And of course, conditional branching. You can take different paths based on different tool results, and you can test things, errors, and things like that as well. So what we're now looking at is kind of, sorry, let me just check in the chat if I've got anything. Da, 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 da. Okay, so Claude Code is an example of a deep agent. Yes, it is. It uses the same actual agent harness as Claude Code does. So yeah, definitely is an example of that. How are skills different from reusable prompts that go into the context window at the right time when needed, apart from progressive disclosure? So I would say so. What you've got there is they are quite similar in a way. A skill a skill, I would say, is different from a prompt because a skill is something that the agent decides whether or not it will use it. By that, I mean, if you write a skill, let's say I've got a skill to say that, let's take my example about the case officer. In a reusable prompt, you are putting that into the prompt every single time. That means that the agent is reading that every single time. And that takes tokens, right? Now, the skill, the way that they composed it is that the agent gets the query, then it reasons and says, hey, if the question is about how do I work with this case, it reasons and says, I think I need the case skill. What skills do I have access to? Then it will retrieve that case skill into its context. However, if it doesn't need that skill, it won't. Whereas with reusable prompts, you're actually sending, if I'm understanding you that question correctly, you're actually sending that prompt to the agent every time and therefore using the context. So that's the reason why I think skills work really well. They're on demand. They're basically ingested as and when the agent needs them. So I hope that answers that question. So actually, this kind of leads quite well into the next pillar, which is memory, right? So you've got different memory systems across agents, right? So you have something like Claude MD, which is the project level instructions that persist. You've got cursor rules. You have the context window, which is the active context window, and that was what I was talking about with that reusable prompt. A reusable prompt will use the context window, whereas a skill will sit outside of it and will be ingested into the context window when the agent thinks it's fit. You've also got conversation history. This is kind of, I think we all know this when you're in a conversation with an agent. This is just tracking everything that's happened in the conversation, everything the user said, and things like that. What you also have is a file system, and this is super important because in the rise of the kind of deep agents, you've got to be able to do something which is called context offloading, which is the fact that when you have some context and you've basically used it to kind of move to the next step, you can then offload it to the file system. Now, this is super important because you can imagine tokens are heavy in terms of just compute and also costs, right? So you don't want to be using tokens unless you have to. And also, the more tokens that you're using, the harder it is for the agent, especially if your context is bloated. It's hard for the agent to really work out what it needs to do. So having the ability to offload files is really, really important. And see, on the right-hand side, you've got these kind of different levels of memory hierarchy. You've got the kind of system prompt, the conversation history, the tool results, Claude MD, and the files on disk. And again, these are kind of the things that your agent has access to. Now, it's kind of outside the scope of this session, but if you're kind of putting these things into production, you need to think about where you store these things, right? So if you've got a file system, this is likely in production not going to be on your local PC. It will be for a agent like Claude Code, but if you put something in production for your users, then you'll need to use something like Postgres or Redis to kind of manage all of that. But that's outside the scope of that and is more about production, things like that. Okay, let's move on. So tools. So Claude Code has kind of 15 built-in tools. Now, tools are kind of the key attribute that allows our agent to interact with the real world. It's the thing that basically allows the agent to go from its memory bound, i.e., when it was trained up until, so you know that most frontier models have a cutoff point. You know, if you ask, you know, one of the models something, they will say, like, we've just launched Minimax on SambaNova Cloud, if you want to go check it out. And its cutoff, I think, is in 2024. So if you want to have more kind of up-to-date data, if you want to interact with certain systems or file operations, this is how you do it, right? And managing your set of tools, making sure that you don't have too many is super, super important. But what we're starting to see with deep agents is these kind of common tools that give you a huge coverage in terms of the kind of things you can do. So the key one is file operation. So you've got to be able to read, write, edit, grep, you know, glob your way through a file system. And you'll see that in coding agents, probably the most common tool, right? To give you an example, when you ask it a question like, hey, I need to add this new feature, the first thing it's going to do is it's probably going to do like a grep and then a glob to try and find any kind of relevant terms and files for that feature and then read them. And again, so you have these kind of common tools that are super, super useful. And then you've got execution, right? So your agent will ask you usually permission, but it has the ability to run code. Now, what's super interesting, and we'll get into in later sessions, is that when you run a local agent like Claude Code or Codex or something like that, the runtime is actually your own computer, right? It's running it on your own computer. But if you think about, you know, security, untrusted code, lots of people use sandboxes. We built an app that we use sandboxes for as well. And that makes it much more secure and isolated per user. And then you've got things like web search, sub agents can be tools as well. You've got MCP servers, and MCP servers is more of a common pattern. Again, this came from Anthropic as well, where you have a common contract in the way that the tool is what's it called, declared, so that each tool has the same kind of declaration. So it makes them kind of interoperable, and they are kind of a type of tool, and you can stand them up. And then you've got kind of, you know, an example of a custom tool like a notebook edit, which will allow you to modify and edit something like a Jupyter notebook or something like that. So again, these are the types of things you can have. Like you can have custom tools and all sorts of things, and of course you can write your own tools, right? So anyone who's been using LangGraph or, you know, Agent SDK can declare their own tool, and in the code we're actually going to go and declare our own tool and kind of write some of this code in LangGraph as well. So with that, I'm going to kind of stop and look at some of the questions and see if there's anything that I've missed. So Snowflake Cortex Code is a deep agent. I'm not familiar with that, so I'm not going to try and answer it. So I don't know, and I think the rest of the questions are around when are these going to be available. So how do you connect no code or low code agents to deep agents definition? Very good question. So I'll actually talk a little bit about low code and no code, and we've been working on this a little bit at SambaNova as well. So low code and no code is essentially a UI, right? To give you some examples of this, Crew AI have a platform where you can just basically type in your query, and then it basically builds you a deep agent in the back end. And I think LangChain also have one as well in Langsmith, and we've been working on one as well. But to kind of give you an example of what it actually does is that you give it a input, and then it has an agent building your agent. So it has a deep agent that then uses the harness, which is basically the code and, you know, the runtime and things like that. It will then generate you a deep agent based on what you've said. So you have a deep agent building a deep agent, and this is a, I would say, a common pattern, and it allows users who are not technical to basically declare agents for themselves. But that's how that would work in the back end. You would just basically declare it, and then it would build a deep agent which would have some of these file operation, execution, and web search as standard when you declare them. So I hope that answers that question. Okay, so one of the key things I think, and this is a day zero requirement, and I always want to say just how important this is if you're going to build agents for production, and what is inside your coding agent is eval. One of the biggest, you know, the things that clients struggle with, and people who are trying to scale agents in general, and I think that's why some of the work that I talked about, out there from Anthropic, from LangChain, from Crew, the eight from ADK from Google. These harnesses are really impressive because they have kind of evaluation built in as a first class citizen. The moment you start writing agents, you need to make sure that they are being evaluated for your use case. And it's evaluating agents is super hard because in part of all of the different connections that I've just talked about, right? They're non-deterministic, like the same input can produce different but valid outputs, right? Every time you do a tool call, for instance, let's take an example of a web search, you might have a deterministic model on your left-hand side, but the tools and the skills and the way that is ingested and analyzed is different. So if you search for the news for what's going on in the English Premier League, you might get a different set of results that would then make the output different for the agent. And that's just things that you have to deal with. They're multi-step, so you need to evaluate every step of the journey. So like we'll get it into it in the code example, but you need to know what is happening in the state of your agent. What is the state on not just step two, but step 200, right? And this is super important for coding agents, because for coding agents, they go over huge time horizons, right? And they do hundreds of steps, some of them. And so you need to be able to evaluate it at every step to ensure that it's not going into what the kind of call the doom loop, where they go off on a track and they just kind of get stuck in there as well. And then kind of like, how do coding agents do it in general? Deep agents, right? So lots of things, right? So built-in verification, running tests after code changes, type checks. So you'll kind of see this in things like Claude Code and Codex and things like that, that they tend to run kind of lint checks after they've made updates to your code. So to give you an example, if you're writing something in like Node or like React or something like that, and it goes and makes a change, a common practice at the end is that it will run like an npm run build. So it will test that the code still builds after it made a change. Now, of course, due to things like skills.md, you can actually define the kind of test that you want the agent to run in that skills.md. So that makes it really powerful. If you say you've got a load of automated tests in your business that you want it to run, you can put that into the skills and make sure that it does it. Now, you've also got industry benchmarks, right? So SWE bench is probably the most well-known one. So every time there's a new model, they are tested against that. And so again, we've launched Minimax at SambaNova Cloud, which is an open source model, a mixture of experts. It does really well on SWE bench, and one of the kind of leading open source ones as well. But this is another way to kind of measure a model against real world tasks. And of course, a a platform to observability is super important. So in this series, we're going to use LangFuse. It's open source, but there are many, many others. There's something called OTel, which is basically the telemetry, the open telemetry standard. And this is where all of the traces from agents go. And so there's lots of solutions that allow you to do that. But I would really, really recommend that from day zero that you have observability of your agents as well. And again, on the right-hand side, I've kind of put this into a pyramid for you, and we've got a whole session of this in section 6 as well. So with that, I'm just going to stop and kind of take some of the questions. Aha, a webhook. A webhook. That's a very good question. So here's a kind of a webhook. So let's say that you want to have an agent that basically summarizes and drafts a response to your inbox, your Gmail. Let's just take Gmail as an example. What you actually need is that normal agents run like on, you just running it, right? What you're saying with this agent is that you want it to run on some sort of trigger, some condition. The condition in this case is the Gmail, a new email coming into that. So what you need to do is that you need to set up a webhook that actually monitors when that email comes in. So that a webhook is basically like an event that tracks a trigger of something. So that trigger could be a new email, a new Slack message, a new Confluence page going up, and that's what the webhook does. So once that webhook is fired, then that tells the signal to the agent, oh, I need to run something. So that is basically an example of a webhook. A webhook is a great way to kind of is to make your agent go from being almost reactive to proactive, and that's something that I think OpenClaw did really well. They have a ton of webhooks in there that basically kind of inform you of things as they're happening. So I hope that answers that question. So pillar five is agent skills. So what we've got here is do, do, sorry, move that again. So what we've got here is the skills that I talked to you again. Again, we're not saying that skills are replacing tools. The two can work um in in kind of what's it called? They can work in tandem. But what we are saying here is that skills is a very nice reusable way, and the difference here is the way they're written. So tools are generally written as code, right? You'll see here you kind of have an act tool decorator for LangGraph and lots of the other agentic frameworks. Whereas with skills, they are written in plain text. So you can see that if something is written in plain text, then it's much easier for anyone to kind of define it, right? You don't need to be a computer engineer. You can actually just say, I've got a skill, just literally write it in plain English what that skill is. And the agent can decide whether or not it wants to use it as well. Very very kind of similar to the way that an agent would discover a tool, but the difference here is kind of the fact that they are written in plain English, and that makes it easier to maintain, right? Because you don't have to maintain a code base. All you have to do is maintain a .md, and you can add to it, and this kind of increases the surface area to lots of like non-technical users who want to basically define reusable things. And that's why I think they've really taken off. They're a really, really neat way to basically extend the functionality of your agent without kind of adding a load of code bloat as well. So yeah, you can see packaged, reusable, well-tested behaviors that an agent can invoke, and they're domain specific. So one of the classic examples here is that if you are doing front-end development on Claude Code, it has its own front end skill. So it has a specific skill that would say, would increase the performance of front end coding because it has lots of, I'm sure, best practices, things like that to do with front end coding. So that's just an example, and then users can define their own as well. Perfect. So you can see, well, I'm going to stop here because there's a GitHub repository that you can kind of follow along here. So what we're actually going to do now is that we're actually going to jump into a demo. So we're going to jump into a demo that talks through some of these things, and we're basically going to run some code in LangGraph. And feel free to follow along. The repo is up. It's super easy to install. It's just kind of make sure you've got at least probably between Python 3.10 and 3.13, and then UV as well. And then that's kind of it. But with that in mind, we're kind of going to move over to the coding. So I see this. So can you explain LangFuse traces a little bit? Yes, if you have a multi-agent solution for implemented rules-based solution, how do you ensure the collection of agents sit the required rule execution path? So that's a kind of good question. So what I'll do, there's kind of two questions in there. With this example, we're actually going to look at a LangFuse trace. So I can actually see one. I can take you through a LangFuse trace and what it looks like in the background, and you'll see that you can see each kind of tool call in the trace, and you'll be able to actually see whether it's done what you think it should have done or it's veered off, and you can see the output of the tool as well. So hopefully I can answer that question through this coding exercise. Okay, so you can see now that we're in the notebook. But first things first, I should go to the README. So the README is pretty straightforward here. There's two things that you'll need. And the first thing I'm going to do is go to cloud.sambanova.ai. So if you haven't signed up, please do go to cloud.sambanova.ai. I'm going to very quickly display to you our kind of, well, what we're known for, which is actually I'm going to log in first and foremost. So let me do that. So once I've signed in, so this is basically all you have to do. SambaNova, you sign in. I think you do give $5 worth of free credit. So if you just need to put your information in, and once you do that, you can kind of use us as any other provider. So here you can see I'm going to use Minimax. And you can see we're known for again, our inference is super quick, and you can see that we've kind of got this out in 384 tokens per second. And if you use kind of even, I would say smaller models, like, let's use GBT-OSS, for example, you can see that, again, our tokens per second are kind of super fast. You've got 769, which is far quicker than the GPU. So if you want to get an API key, it's pretty simple. You just kind of go in, go to API keys, go to generate. So you go here, and then you just basically generate, and then you'll get an API key. And that API key you can use in this example. The only other API key you're going to need for this is Tavily, which is a search provider. Just go to Tavily and you should be able to get an API key from there as well. Perfect. So without further ado, once you have those API keys, just follow along. So what we've done here is I'm just checking that the API keys are present. And of course, LangFuse is the observability platform. Again, LangFuse is both hosted and cloud. You can go onto LangFuse, get an API key. I'm running I'm running LangFuse via their Docker self-hosted. I've put all of that in the README if you wanna run it. But if you don't want to kind of mess with any of that, you can just go onto their website and get a key from their hosted version. And these traces are now enabled, so we should start to see them in our LangFuse dashboard, and then hopefully I can kind of answer that question a little bit around what a LangFuse trace is and how it stops your agent from going awry. And I can see one of my colleagues has joined the chat, and he's going to help answer the question. So good to see you, Seth. Okay, so what is a React agent, right? So as I said, reason, act, observe. Basically, it separates an agent from a simple LLM because it plans, it uses tools, and it iterates to solve complex problems. So what we're going to do now is we're going to answer this question using a simple chain. Now, you can see here we're using Minimax. We are basically going to ask it a question about research. Now you can see it answers the question pretty quickly, right? But what it doesn't do is it doesn't really plan. It does do a little, it's a reasoning model, so it does do a little bit about the thinking, but it doesn't have an it doesn't have an explicit plan step where it kind of iterates through a plan like a to-do list, say, hey, I've done this, I've got this to do. And it also can't access anything externally. So currently, that's kind of like the vanilla simple chain baseline. So what we're going to do now is that we're going to add some tools. So we're going to add 3 tools, right? And again, in the next session, we're actually going to get into, we're going to do more of a deep dive into the code here, and we'll talk about how this code runs, how they're declared, how the state is managed. But for now, we're just going to kind of run through the code so I can show you an example. The three tools we're going to use are web search, write to-dos, and write file. Now, the reason I'm using this is because these tools are actually what are inside your coding agent. So, Claude Code has one. You'll see it has a little to-do list, right, where it checks things off. So this is how these things are actually implemented in code. And this is what's happening in the background when you do that. So here, what you've got is you've got these three kind of tools that I've declared. I've got a to-do, and you can see here I've declared the things that are in there. You've got the file reducer, which is basically reducing the files and when we save them and making sure that we don't have any duplicates. And then we've got the state of the actual agent. And this is super important, right? We must track the state. And what the state that I want to track is the to-do and the files. So we're just going to do that. Perfect. And then here's the thing that I talked about, defining a tool. And in LangChain, it's super easy. And I think in a lot of the providers, Crew AI, they basically have all converged around this standard at tool decorator. So you just basically add this to your function, and then it becomes a tool. And you can see this is nothing crazy here, right? I'm just importing Tavily. I'm getting the search results. I'm capping them at 3. And then you can see here, I've got a write to do. And this here, we use the kind of command. And what the command does in LangGraph, it allows me to get the state and to basically update something in the agent state as well. And then the next thing is the write file. And so here I'm basically, again, using the command object. So you can see here that I get the files, I get the file path, and then basically the command here is to update that with the output of the tool, right? So again, we'll go over this code in a little bit more detail, but for now you can see that the kind of the tools are defined. Now, then the next thing you need to do is basically give it a system prompt, right? I think we should all be familiar with this. The system prompt is something that the agent reads every single time. And so if something is happening in the agentic workflow, the system prompt is read every single time. So this is super important because it's the thing that the system sees all the time, right? And here, all I'm going to do now is kind of go into the kind of the create agent and visualize the graph. Perfect. So then what we're going to do now is, and again, this is, again, let's kind of look at this graph a little bit. You can see here the kind of the React loop, right? So we go to the model decides, do I need a tool or not? Okay, call a tool, get the result of the tool. Do I need a tool or not? Have I answered the user's question? And so on and so forth. And here, but the difference here is that in these tools, within deep agents, these tools have now things like the ability to execute code and also to plan and to kind of reason with the to-do list. So now what we're going to do is that we're going to run this kind of same task, but we're going to run it with these new kind of these new tools from the agent harness, that are to-do list and the web search tool as well. So while it's doing that, I'm going to kind of read the questions. There's nothing here. So what I'm actually going to do now is I'm going to go back to that question that someone asked about Langfuse. So let's go into Langfuse and let's actually look at some of the traces, right? So we're going to go into here, and we're actually going to look at, so here we go. So let's actually look at some of these traces. So here's actually something that happened earlier, right? So this is the research node. So this is actually the question that we've just asked, right? So what's important here is that you get the output, you get the input, and you get the output of everything that's happened, right? And you can see basically it's gone into the agent frameworks, it's gone into this. Now, this is good, right? But the key thing that makes it super useful is that you can see what it's done. You can see that it's got the right to-dos. So this is where it's super cool, right? So if you can see, it wrote a load of to-dos, right? You can see here, pending, 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 right? So the reason why there was a question, how does a lang fuse trace work? And this is the same for all agent traces. They give you exactly at each step what the agent did, what tools it called, what the input and output was. So you can actually go through each step and make sure that the input and output is what you expected from a user perspective. And if you go down here, you can see this is what Chat SambaNova did. You can see the web search, right? So you can see the web search here was a success. And you can also see exactly, yeah, you can actually see the output from the web search, right? So you can see here, these are the pages that it got. And you can see I had three, right? It's the top three, 1, 2, 3. And so it allows you to go step by step, and then you can see the results of the tool call here, web search, chat SambaNova. And again, when we go to the right to-dos, here's the cool thing. As it completes that task, it marks it as completed, and then it moves on to the next thing. So this is a huge thing with the deep agents, right? The ability to plan and to follow that plan like a to-do list so it doesn't forget where it is, right? And by looking at a trace, you can see exactly what's happening at any time. And that's why these are like a day zero requirement. If you're really serious about putting these things in production with real user data and you want results that, you know, are kind of repeatable and robust, then having this kind of observability where you can really dig into every step of the agent, like this was a fairly simple query, but you can see that it basically yielded about 30 steps, and that's why it's super important. Okay, so I'm just going to kind of go back to the chat, and I can't see anything. Um, so how to ensure the performance of an agent maintained once it's released to production? That's a really good question, LET. There's many things that you can do. I think guardrails, um, input kind of sanitation, output sanitation, observability, humans in the loop, and really just very, very robust testing. But there are a lot of things. in addition to that that you can do. And we've got a session, the last session here, where we're actually talk about this explicitly. But as I go through these sessions, I'll be talking about some of the tools and techniques. But observability is the first thing. You can't improve what you can't observe. So that's the first thing. Make sure you've got a really strong observability pipeline, and you can see here step by step what it's doing. And then, of course, things like guardrails, sanitation, making sure that you're protecting your users, approval for destructive actions, making sure that agents can only access what they need to access. Super, super important. Anyway, so I just wanted to kind of go off there and kind of talk about that. Now, here you go. So you can see here, this is exactly what we've just seen, right? But on the flip side, so you can see here, human, this is what I ask. The AI, the first thing it does is it calls the tool. There's the tool call. And you can see it's researching. And it goes and does the research, and then it gets that information, then it completes it. Then it goes and does the next thing. So this is what I mean. And then you should see completed in progress. It does that until it's absolutely completed, right? So here we seem to have got an error, probably with the computer use tool or something like that. But you can see that essentially this is essentially what it was trying to do. And by doing this, you'll be able to basically run this. Yeah, you'll be able to run something like this and follow through exactly what the agent is doing. So again, what I showed you was the flip side of this. So essentially the behind the scenes look, but what you're seeing here now is the kind of the front look, right? So going through and looking at the actual state of the agent as well. So while that kind of runs again, so I think we had an error there, I'm going to kind of go through the agent state, right? So you can see, for instance, here, and I can actually show you from the back end because it's probably easier, is that when there's a simple chain, going through what it produced is super important. So the inspecting the to-do list of your agent is super important, right? So as you can see here, duh, 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 okay, so this one is now finished, right? So this one finished, it updated the to-do list, and you can see here at the end, your to-do list should be complete, right? And what is great about these systems is that you can actually add custom things. Like the to-do list tool was a very kind of naive to-do list tool, right? You can imagine like with more complex coding agents or custom agents, you could customize your to-do list to be, you could always say, hey, at the end of your to-do list, always add a step for verification, right? You can say, make a to-do list and then add an extra to-do list that says verify your steps above or something like that. So you can see how it becomes a really, really powerful tool. Um, and so then what I want to kind of tell you is how do we inspect the state? And again, why traces are so good is that they do this naturally, right? So they inspect the state naturally. What I just showed you in Langfuse is basically this state for every single step in a really kind of structured way. But of course, you yourself can actually inspect the state via code, as you can always access everything by code. And what you can see here is that what did we do? You can see the to-do list. You can see that I wrote a file, and then and then of course I actually, because I have these kind of write file permissions, but you can see the difference in the fact that from the naive chain, we were able to do tool calls and things like that. So the difference here, as I said, breaking down what we built, we kind of had a symbol chain versus agent with tools. You were able to the state agent's memory, tools with command, writing back to the state, the React loop, and then basically, as I said, this is just the beginning. We're going to cover different kind of parts of this, what we've just gone through in specific sessions, and go into a bit of a deep dive as well. Um, so, does it mean that we can control our agent planning phase? Yes. Yes, yeah, exactly that. You can, so Aditi, you can force in your system prompt that, the model here was smart enough to use its to-do list. But what you can say is as well that you can see actually if we go back to so that we cover this, um, the system prompt. So here you go. You're a research agent. you follow this task plan. So you can see right here, this is the key. I've told it in the actual system prompt to use the to-do list. Now, so this is where you can be really specific. That's why you see these coding agents actually use that. That's why Claude Code always uses it. It's the first thing it does. So in our agents, we build at SambaNova, the first thing we write is use your to-do list. Always use your to-do list. Always be tracking what you've done. So it's a super great way of making sure your agent stays on track. So yeah, that's the kind of code portion. Again, this code is all in the repo. Feel free, change it yourself. I always say the best way to kind of learn this stuff is just to kind of go away, hack at it, and understand what's going on underneath. There was a question here about kind of, is it a good time to be an AI engineer? I'm probably going to leave that. I'm sure that's a hot button topic, and many people have opinions. But yeah, if you want to connect with me on LinkedIn, I can probably give you my take on that. I think it's always a good time to be an AI, but I think you've got to also use kind of these new tools that we've been given, but not rely on them too much as well, because I think people need to really understand what goes on underneath. Um, so will the permission check write file permissions be done proactively or at runtime? Duh, duh, duh. Let me see. So let me see if I understand that. Will the permission check write file permission be done proactively or will it be done at runtime? It will be done proactive. It should be done. I'm not sure I understand that question, but the you'll need to give if it's a write file, then it will need to have permissions to write to wherever you told it to write. If you told it to write to C desktop, it will need permissions to write there. Or you can basically in your tool find a way to approve that action. So this is kind of up to you, and I would highly recommend that when you do have write file, in that example, it was a virtual system, right? So it was writing things in its memory, and that's the safest. And whereas with Claude Code, of course, it can actually do things to your computer, so you want to be a lot more careful as well. Perfect. Okay, so again, I want to make sure we've got some time for Q&A at the end and a couple of things that we've done with SambaNova. This is kind of the kind of simple six step journey that I want people to go through. Define your use case, standard operating procedure, the MVP, orchestrate, test, and deploy. We'll be talking about this a little bit more in detail in each session, but it's a really good way of thinking about building the agents. So I love this kind of smart intern test. If can a smart intern test do this with clear instructions? Yes. If not, complex, break it down. I think one thing that deep agents are really good at, and you saw it in the to-do list, is breaking things down. They take complex outside questions, break them down into manageable ones, go and do the manageable ones, put them back together. And again, the kind of red flags that you've got here, if you can't find concrete examples, it's probably too broad. Do you need agents? Is it deterministic? If it's deterministic, you can probably use traditional software. And if you're connecting to APIs that don't exist, you might be trying to build something that doesn't quite exist just yet. Um, Connect, test, deploy. I think we've talked a little bit about this. Make sure that you've got the right databases, files, skills. Make sure you test via traces, and then make sure you deploy and monitor. Now, this is a huge thing, and again, we think something that we are tackling in SambaNova. The total cost of agents is prohibitive. Our hardware makes it easier to run many models quickly with high throughput, and I'll talk a little bit about our new chip that allows you to do that as well. And deep agents in practice, you've kind of got things like Claude Code, Windsurf, Devon. We have our own chat.samno.ai. Feel free to go and check it out. It's our own kind of agentic platform that we use. We have a runtime and things like that. So feel free. But there's these things are really, really taking off, and they really are allowing people to work much faster on many different domains as well. And I'm sure you will have heard some of them as well. So kind of key takeaways. So coding agents are now the blueprint, the harness, let's use that word. We're seeing a lot. It's the harness, right? The harness is these set of tools and instructions and code that sit around your agent. You can swap the model in and out, right? You can use kind of Opus, but that might get expensive. You might use SambaNova for other things. You might use another provider for other things, right? These 5 pillars, always think about that when you're building agents. The 6-step development process, the smart intent test. If it's too difficult, break it down. And then deep versus shallow agents. So you can actually try the deep agents repo at the moment. It's there live, and the next session is going to be on March 25th, where we'll actually go through that React agent, and in detail. We kind of went through it quickly there, and I'll talk a little bit about why lang you know why these architectural decisions have been made, and what I mean when I say a harness, and why a harness is good. So we're going through from scratch, so you understand these concepts, but actually harnesses actually have these built in. So they have built in to do tools that you don't have to re-implement yourself. But I always say if you really want to understand something, do implement it yourself so you can. So I'm going to stop there, and I'm just going to kind of basically go on to this. So we at SambaNova, we kind of we we know that agentic runtimes are expensive because many people are spinning up many agents. The end-to-end latency is a big deal, and the total cost per task is also a big deal. So we've basically built a chip that we think is really attractive for agentic workloads. So you can check it out in the blog, but everything that we've talked about, right? It's kind of, if you run agents for 2,000 users and you all have a coding agent, then two things matter to you, right? Like how many tokens you produce, how many users you can serve, and how quickly you can serve them. So we think that our next chip really sits in this Goldilocks zone. Here you've kind of got GPUs on the left-hand side that are really good for throughput, but are bad for latency sensitive stuff. So if, for instance, agents are latency sensitive, if they take ages to compute, as you can see sometimes with your Claude code, it can take minutes, sometimes hours to do a thing. Now, batching is good for tokenomics, but it means the latency is slow. Whereas on the other side, you've got super fast providers, but they're prohibitive because in order to serve a lot of users, you've got to buy a lot of hardware. So our chip basically sits in the middle, and it gives you the best of both worlds. And again, we've kind of delivered some really impressive numbers with low power. So I would advise you all to kind of check out that in SambaNova, in that blog, and basically go onto our cloud, start using it, and then kind of yeah, get started building agents yourself, basically. So let me just go to here. So that was one of our that's our chat.sambanova app if you ever want to go there. But that's all that I wanted to cover. I'm sure I didn't answer all of your questions. So sorry if I didn't. But that kind of brings us to the end of the session. So I'm going to hand over back to yes, the folks at Data Science Dojo.